the tree, if it refers to the tree that I have just mentioned a moment ago, is that genetically modified tree, meaning that we use the DNA from the trees to make the tree grow well and then to increase the fruit, something like that.
Mm-hmm.
Yeah, but this is to my understanding here.
Yeah, that's is right, Bong. So there is a reason why people use genetically modify food, or why do they need to modify the genes in food, right? Sometimes they want the food to last longer, maybe sweeter, maybe you know has higher yields, or
Mm.
actually bigger, right?
Yes.
Or in the case of cows, they want them to have more uh, fats, for example. All right. In the case of vegetable, they want it to be grown bigger, for example. Right. So
Mm.
I found a video. Let me check. Genetically modified food that explained it very well on. There are a lot of food choices out there, and moment. Do you know what GMOs are? Do you know what GMOs are? Okay, GMOs are one of.
And that
It's this one.
it does relate to the climate adaptation.
Mm,
Because I see a lot of experiment that they use the genetically modified plant for adapt the situation, adapt the
mm,
climate change as well. For like some of the rice seed, and they can produce a lot of yield and can use very small amount of the waters.
Mm. Yes.
that,
That's mm,
yeah, that is right, right. So I think when a person go to modify a gene inside of a food, right? There tends to be a reason, right? So a reason could be like what Bongwan said, for it to withstand or adjust to its environment or its climate, or whether you want it to last longer, or you know t- typically like grow bigger than it used to be, right? For example, so there must be a reason as to why we want to genetically modify something, because you know your gene, right, it defines who you're gonna be like, right? So uh if your gene says you are gonna be this tall, you're gonna be this tall, right? If your gene define as you are going to be a basketball superstar, you're gonna be a basketball superstar. Right? So it all's in the gene, all right, mostly. Okay, we'll play this video a little bit, but the question is it still natural, and is it still safe to eat genetically modified food, right? When something has been touched, something has been changed, and it's not natural anymore, is it still good? And then the question is, we've all been eating genetically modified food for probably centuries, and for many of us, we consider those genetically modified food as natural as well. And I'll let you watch that and decide for yourself. Okay.
GMOs are one of the most controversial areas of science. Genetic engineering is used in many fields, but even though medical applications like GM insulin are widely accepted, the debate heats up when it comes to food and agriculture. Why is that? Why is the same thing treated so differently? Let's try to get to the bottom of this and explore the facts, the fears, and the future of GMOs. Humans have been genetically modifying plants and animals for thousands of years. Maybe a few of your crops had very good yields, maybe one of your wolves was especially loyal. So you did the smart thing and bred the plants and animals that had traits beneficial to you. Traits are just an expression of genes. So with each generation, those genes got more pronounced. After thousands of years, almost every single plant and animal around us is vastly different from its pre-domesticated state. If humans have been changing genes for millennia, what makes a so-called genetically modified organism, or GMO, different? Selective breeding is basically hoping for lucky hits. Genetic engineering eliminates this factor. We can choose the traits we want, make fruit grow bigger, immune to pests, and so on. So why are people concerned about them? Let's start with one of the most common objections to GMOs. Gene flow, meaning GM crops could mix with traditional crops and introduce unwanted new characteristics into them. There is a method that might guarantee complete prevention, but is a big anti-GMO argument by itself: terminator seeds. The idea is that they could produce sterile plants, requiring farmers to buy new seeds every year. The very concept of this, however, caused a public outcry, stopping the technology being put to use. This brings us back to the unintentional spreading of engineered DNA. There have been cases of GMOs growing where they weren't planted and traces of modified genes found in foreign crops. But GM plants can't run wild entirely. Many crops pollinate themselves, and all crops have to be related to mingle. There are also cultural methods like buffer zones to keep unintentional crossing at a minimum. But if it's possible in principle that a GMO could unintentionally cross with a non-GMO, there's actually a more important question. Is food that comes from GM crops different to food from non-GM crops? This question has been a major concern from the very beginning. GM plants that are destined to be eaten are checked for possible dangers, and the results are evaluated by multiple agencies. After more than 30 years and thousands of studies, the science is in. Eating GMO plants is no more risky than their non-GMO equivalent. But don't just take our word for it. Sources for this and other claims are in the video description. But what about plants that have been engineered to be toxic? For example, Bt crops. A gene borrowed from the bacterium Bacillus thuringiensis lets engineered plants produce a protein that destroys the digestive system of specific insect pests. The plant makes its own pesticide. Insects that eat it die. That sounds alarming. Pesticide sprays can be washed off, while the poison in Bt crops is inside the plant. But actually, it's not a big deal. Poison is really just a question of different perspectives. What's harmless to one species might kill another. Coffee, for example, is a poison that kills insects but is harmless to us. Or take chocolate. It's dangerous for dogs, but a pleasure for humans. Bt crops produce a protein that is tailored to the specific design of the digestive tract of certain insects. It's completely harmless for us. There's also the opposite approach: plants that are engineered to be resistant to certain weed killers. This way, farmers can use them widely, killing the other plants competing for resources without harming the crop. Here we get to the dark underbelly of GMOs. For the pesticide industry, they are big business. Over 90% of all cash crops in the US are herbicide resistant, mostly to glyphosate. As a result, the use of glyphosate has increased greatly. That isn't only bad. Glyphosate is much less harmful to humans than many other herbicides. Still, this means farmers have a strong incentive to rely on this one method only, casting more balanced ways of managing weeds aside. That's one of the most fundamental problems with the GMO debate. Much of the criticism of this technology is actually criticism of modern agriculture and the business practice of the huge corporations that control our food supply. This criticism is not only valid, it's also important. We need to change agriculture to a more sustainable model. GMOs as a technology are actually an ally and not an enemy in that fight, helping to save and protect nature and minimize our impact on the environment. Let's look at some positive examples. Eggplant is an important crop in Bangladesh, but often whole harvests are destroyed by pests. Farmers had to rely heavily on pesticides. Not only was this very expensive, farmers also frequently got sick. The introduction of a new GM eggplant in 2013 stopped this. The same Bt protein we talked about before, an effective killer of insects but harmless to humans, was engineered into them. This reduced insecticide use on eggplants by more than 80%. The health of farmers improves and their income rose dramatically. And sometimes a GM approach is the only option. In the 1990s, the papaya industry in Hawaii was under attack from the ring spot virus, which threatened to wipe out Hawaiian papaya. The solution was a papaya genetically modified to be vaccinated against the virus. Without it, the state's papaya industry would have collapsed. All these stories show a very narrow application. 99% of all GMOs we use right now produce pesticides or are resistant against them. There is so much more we could do. Scientists are working on GMOs that could improve our diet. Plants that produce more or different nutrients, like fruit with higher antioxidant levels that help to fight diseases, or rice with additional vitamins. On a larger scale, we're trying to engineer plants that are more resilient to climate change. Plants that can better adapt to erratic weather and adverse soil conditions, making them resistant to droughts or floods. GMOs could also not only reduce agriculture's impact on the environment, but actively help to protect it. Scientists are working on crops that can draw nitrogen from the air like microbes. Nitrogen is a common fertilizer, but its buildup pollutes the groundwater and speeds up climate change. Plants that collect their own nitrogen could fix two problems at once: the overuse of fertilizers in the developed world, as well as the shortage of it in developing countries. We could even modify plants to become super effective carbon collectors like the American chestnut tree, to mitigate and actually reverse climate change. With the tools we have today, our imagination is the limit. The world eats 11 million pounds of food every day. A UN estimate suggests we'll need 70% more by 2050. We could grow that food by clearing more and more forest to create fields and pastures, and by using more pesticides. Or we find a way to do it on the land we've got right now with more effective methods like GM crops. Intensifying farming instead of expanding it means GMOs could become the new organic. In a nutshell, GMOs have the potential to not only drastically change agriculture, but to also dampen the effects of our own irresponsible behavior. GMOs could be our most powerful weapon to save our biosphere. This video took more than 600 hours to make, which would be impossible without viewer support on patreon.com. If you'd like...
Okay, so let's hear a thing or two you got from the video. It's quite long, but it's detailed in a way as well, addressing what GMO is, the benefits, the downside, and so on. Okay. All right, maybe one or two things you learned from the video. Perhaps start from Bong one time.
Yeah, teachers, yes, is quite good. Looking at these videos, the GMOs, and in overall, they talk about the benefits of GMOs and also the disadvantage of the GMO as well. I think the benefit is they can the GMOs can save us from, for example, save farmer plants from in Bangladesh, from eggplant from Bangladesh to fight with the pest, and they can produce good yields, and also the GMOs can save the papayas yields in the US as well. They use the modified papayas and they introduce it in the US, and it can produce good yields. And also in the US they also use genetically modified tree rates to produce more yield crop, and also resistance with climate change as well. And but there's also some disadvantage as well, like for example, if we compare between the GMOs crop and the non-GMO crop. The thing is, for example, if we use the genetically modified rice seed, maybe for example, if we plant the GMO this year, maybe next year we do not have the seed to plant again. We need to go to the lab and produce the GMO seed again because the seed from the GMO is not good. And also the GMO also some kinds of the GMOs also produce the pest as well. For example, they introduce a new technologies or new species, but that new species is also produce some pests, some insect as well, right? That is another impact of the GMOs. But in overall, uh, based on these videos, we can say is that if it 50% that we need to use the GMOs, genetic modified plants, food, and trees, as well as we need to rely on our non-GMOs product as well, because to balance the food safety, we need to balance it. But I think based on this video, maybe it would be a little bit hard to balance the food security if if the climate change impact is become exacerbated. I mean, it become more stronger and stronger. So the GMOs may play an important roles in the future, I think. Yes, this is my idea. That's it here.
Okay. All right. Thank you so much, Bong. All right. How about Bong Monet? Can you add one or two more things you got from the listening at the video?
Yeah, I grab only 3 points that would like to raise up. That's a lot of benefit from the GMOs that the video show us. The first is the GMO will be provide the benefit for to extend a good yield, and but secondly is kind of extend the lifelong growth, and third is led to the savings the biosphere and saving resource. But one thing that I noticed is even we have the GMO, but the scientists still keep the qualities of the crop as well. And one more thing is like benefits of the GMO is kind of the fighting with the pest disease, the crop disease, and the pest by by reusing from the chemical pesticide. But the GMO can replace by using that. This is what I grabbed from a long videos. Thank you, Jack.
Okay. Well, thank you so much. And how about Lee Kim? Can you add
Yeah.
one or two things?
Yeah, sure. That what I noticed is like GMO, like they said, it's very good if they are want to have kill the animal that eat their plant, or so it's very good. And also I think if they change DNA as well, what they need to what they want. And so they use GMO is also a good plan as well if they want to a big vegetable, like bigger and bigger. So that's all what I noticed.
Okay, very good. So I think everyone got it, right? So GMO simply made changes to the food, right? Either to make it grow bigger, to have to grow with pesticide within it, right? So that you don't really have to use pesticide on the food, like in the case of Bangladesh. So it saves you from using pesticide, and also it keeps a farmer from being sick as well. All right, and simply the use of GMO, they use the word selection breeding, right? So they breed plants together, or they breed animal together to get a desired quality or characteristics that they want, right? So they bring plants with similar characteristic, match them together until they get the one that they really want, right? So selection breeding is an important word in this topic, as well as you will be learning about flavor saver tomato, and they will also talk about uh, selection breeding as well. Okay, and if you look at dogs, right, or domesticated dog, right, so they're simply wild animal, and for some reason we were able to make them friendly and listen to us. All right, so that's it's not what they are like or how they are born to be. All right, even your pigeon, they are very friendly at the park. All right, and you can walk past them and they don't care because it's been years and years of breeding until they have these particular characteristics that they're not fearing human anymore. And similarly to dogs, like the case of